So thank you for having me, and thank you to Aris for organizing all of these amazing events, both in London and the rest of the world. I heard that they might be coming to Berlin, which I'm very excited for, so let's see. How many of you know about Prisma? It's a good amount of you. And how many of you use Prisma day to day? Also a pretty good amount. That's very awesome. One thing you need to know about Aris is that he has a great sense of humor. So obviously he had to put me next to Matteo on the website. I'm just trying to tell you about my little ORM thing, and he's out there saying, would never use an ORM. Okay. Luckily, Matteo has also said nice thing about Prisma in the past, so I feel good. But there is something about this. People don't like ORMs. And why is that? What is the problem with ORMs? So I'm going to tell you my personal story about why ORMs suck.
Can I record it?
Of course. When I got into professional software development 15 years ago, I joined this little startup in Denmark called Trustpilot. And this is a familiar story. We were 3 guys building a thing, moving really fast, and making a huge mess of it. But of course, we're using an ORM. So Trustpilot is essentially a site where you can write reviews of stores you buy stuff in online. You can go and check other people's reviews before you buy something. So let's analyze this page together. On the right side, there's some static data about the web shop. Pretty simple. On the top, there are the rating for this site. This one was complicated and a different kind of mess we don't need to talk about today. And then at the bottom, there are the reviews. And this was in... of course, I'm going to stand over here. And this was in 2008, so everything is server-side rendered. Like old school, easy to understand. And for SEO reasons, we wanted to show the first 100 reviews on the page. And that's going to be important in a bit. And then the reviews, they're not just the reviews. They're also the author, the name of the author, and a little bit of other information about that author. So how do you load this data? We were using C# at the time. It should be familiar to people who don't use C#. But essentially, you load the company from the company ID, then you go and load all the reviews, do that one by one, then you have all of your data, you pass that to your view engine, and all is good. Except you have this detail that you need to also render the author. And now you have the review, you just pass that into the other thing that is supposed to render the review with the author. And so in line 11 here, you just write your business logic, you do review.author, that's your author, now you can display it. And the ORM will just make this work for you. This is one thing that is different between new ORMs and old ORMs. ORMs will do this thing. They used to do this thing, they would just do blocking I/O. They would pause the thread, they would go to the database, come back to your program. You don't know anything. It just looks like a normal accessing local data. But it isn't. In this line 11, it actually goes out and talks to the database. And because this is kind of hidden from you, as a developer, you don't notice this. As somebody doing code review, it just looks like you're running a function. It could be very difficult to spot, and you end up with this n+1 problem. It's a very familiar thing. There are talks about it. There are tools that will find those for you because they're so common. And it is issues like this that are causing people to say, ORMs suck. I'm not smart enough to use this thing. That's not really how ORMs work anymore, because we've learned from this. And in fact, we have learned from GraphQL. So if you use Prisma or other ORMs that kind of look like Prisma, it is much more like using GraphQL. In the beginning, you perform all of your I/O, you specify what data you need, and you let the ORM just go and fetch that for you. Then you can do your business logic, then you can render your view. You don't have this issue of things happening in between. And then our runtime has also gotten smarter. They support asynchronous operations. So instead of just blocking the thread, going and do the work and coming back to you without having that be explicit in the code, we do this. We make it an async function, we await it. It's very easy to spot when there is a potential for slowness because of I/O. So really, ORMs were designed in this way because they had a really simple runtime. There was no affordance in the language for dealing with asynchronous I/O. There was no such thing as non-blocking I/O in C# when we were doing this thing. So the ORMs were really trying to help you with that. They were essentially providing a runtime for doing I/O. And because of that layout, they had to introduce multiple layers of caching. So if you've ever used Hibernate or nhibernate in C#, you'll know that there's a first level cache, there's a second level cache, there's all of this machinery going on to try to make it fast. Neo-ORMs are different. They're much simpler because they don't have to provide this runtime for you. Node has it already, and it's really nice. So we get to be focused on providing a great developer experience instead. And now I'll try to show you the developer experience of Prisma. I'll make it relatively quick because many of you have used Prisma. So very similar to Hasura, when you use Prisma, you can either introspect an existing database, and that means we will generate types for you for your entire database. Or you can start from scratch and you can use Prisma to model your data and evolve it. So let's create a folder. Yes, of course. Is it big enough? So when you start a new project with Prisma, or you want to start to use Prisma in your existing application, you can run this init command, and that will do a little bit of scaffolding for you. Let's see, is this big enough for us to view? So most interesting, there's a Prisma folder, there's a Prisma schema, and this is kind of the foundational configuration you need to use Prisma. There are two concepts. There's a generator, which just is the thing that generates the code for you, and then there's a data source, that's your database. By default, Prisma suggests you use Postgres because, yes, Postgres is the best database, but you don't have to use Postgres. In fact, Prisma supports most relational databases. We support Mongo, we support SQLite. This thing right here is what is really nice about Prisma. You get auto-completion for everything. So even when you're in this weird configuration language we've created, there's auto-completion for you. So let's try to use SQLite. Prisma also suggests that you use environment variables to pass in your secrets, but we don't really care about that. So let's just write it here. Let's call it database, something like this. And then, of course, we can start to model our data. And let's just create something simple. Let's create a model to track all of us. A model is essentially a table, and we need something. Look, this is the other awesome thing about Prisma. It'll tell you what you need. There are red squigglies, and they mean we need something. And it will tell you what it is. When you have a table, you need to have some unique column. And it suggests that you create an ID column, and you give it the ID attribute. And let's make it a string, because that's what I like. And then we can use the default attribute to just have the system generate an ID for us. And we could make that a CUID or a UUID. That's really nice. Let's also have a name. Again, auto-completion. We can format the document to be nice. OK, let's turn this into a database. Prisma has two different ways to do that. You can either use db push, which will just sync whatever you have in your schema to your database. That's really nice for local development. Or you can use proper migration files, so you have a full migration history. Let's just go and do this. Oof. Aha, I need to save my schema file. So your database is now in sync with your schema, done in 8 milliseconds. That's nice. then it's also running generate. I think something is slow because of the internet. That's all right. Let's give that a second. So it generated my database. There's now a DB file. That's a SQLite database. It's not being displayed because it's a SQLite database. I think this is because I'm trying to download the internet. Let's just give that a second, and if it doesn't work, then we'll move on. While that is going on, we can go and continue our data modeling. So this is a simple table. Let's extend it a little bit. Let's introduce one more model and try to create a relation between them. So let's create a conference model. Let's give that an ID too. Thank you. This is why pair programming is great. And then let's try to create a relation to our attendees. So at a conference, you're going to have participants, let's call them that. And that's going to be a list of attendees. Again, we get auto-completion. We could turn it into a list. But we get the squigglies again. That means we need to do something. It is saying the relation field participants on model conference is missing an opposite relation field on the model attendees. So you can either run Prisma format or add it manually. Let's have the system do it for us. That sounds nice. And in fact, you can use the format command in VS Code, and it just does that. So what did it do? In relational databases, the way relations work is you have a simple field in one table that references another field. So in this case, we have the conference ID field will reference the ID field in the conference table. So Prisma will help you manage these relations. It's very explicit in the schema. You don't lose any fidelity from what the database can do, but it's easy for you to write it and to progress it. My downloading the internet thing is not going super fast, so let's just skip that. Let's skip that. What I wanted to show you was the auto-completion, but you've all tried that anyway. You don't need me to show you. If you want to play around with Prisma, or maybe explore more things it can do, then we have this playground, which is pretty cool. It's an online environment where you can go and do everything. You don't need to download the internet. It just works there. It will spin up a Docker thing for you so you can run all the code. And there's a bunch of things to try out. So instead of going through the docs, this is a really neat way to figure out what you can do. And also on the right side, there's this entire tutorial to try out different ways to run Prisma Migrate. But this talk is about crazy things you can do with your ORM. So let's talk about that instead. Late last year, we introduced Prisma Client Extensions. It's our extensibility framework. And since then, we've seen a lot of companies, for example, Redwood, create really neat extensions. And I want to just show you what extensions can do. A really simple example is the concept of a computed field. Let's say you have this model, a user. It has all of these fields, but you want to add a new field, a computed field, and we could call it name and age. And let's say it should render something like this. The name followed by the year or the age of the user. In normal ORMs, it's kind of simple to do because they're based on classes. You can just go and add new fields to the class. But they also kind of relied on the fact that you would always load all of the data. So what happens if you have many fields? Some of them are really big, and with Prisma you can say, I just want to load those 3 fields. How are the computed fields going to work then? Because they need to rely on some specific information that has to be there. And this is a very simple example, but you can imagine much more complex examples where specifying a data requirement is really important. So So this is what that looks like with the Prisma extensibility functionality. You can instantiate a Prisma client, and then you can use this new extends keyword to create any kind of extension. This is the most trivial thing you could think about. It extends the user model with a new field called name and age, and it specifies its data requirements. It needs the name and the age fields, so they have to be loaded. And then the computation is just simple JavaScript. And here's an example from the playground, just showing you that the auto-completion works when you do this. The types are correctly inferred. So you actually get that name and age field on the return data. This is a thing that is really cool about TypeScript. Definitely way, way cooler than C# and all of the other things we were doing before. You have the structural typing. Some people call it duck typing. And you have this very powerful type system where you can run Turing complete code in your type system. It's kind of weird. Prisma was one of the first libraries to really embrace that and try to push it to the limits 4 years ago. Now lots of other tools are starting to do that. gRPC is really cool. They're also pushing the limits. But these are the kind of things you can do with that. And then because AI is about to take over the world, we all know that, you could do something like this. I bet most of you could sit down an afternoon with just the stuff I showed you and implement Prisma.ai. Return all users whose birthday is today. You could implement this as an afternoon with these extensions and with the OpenAI API. Getting the types to work, probably going to take another afternoon, but it's a fun exercise. And we're using this system of client extensions to build what we call the Prisma Data Platform. The Prisma Data Platform is using client extensions to augment Prisma with cloud functionality. The first example of this is a product we call Accelerate. Accelerate is a global database cache available in 280 locations with built-in connection pooling. It will make a database faster, help with scalability, and it's easy to use. So there's this thing going on right now where we're all learning how to deploy our applications closer to the end user. Netlify, Vercel have edge runtimes now. Cloudflare will run your code in 300 different places. Really cool, and you can deploy this like nothing. You don't need an afternoon for this, you need 5 minutes. But bringing your data with you to the edge is really complicated. And I know that Fly.io has some really cool stuff going on where you can SQLize and you can replicate your data around. It's a little complicated. With Accelerate, we're proposing a much simpler model. Keep your data in one place. That's easy. But then cache it close to your applications. So if you deploy your code to Vercel, to Netlify, to Cloudflare Workers, then you can run your code within like 30, 40, maybe 50 milliseconds from most human beings in the world. And if you also cache all of the relevant data in those same locations, well then most of the time you can serve a full page in 50 milliseconds. That's really cool. And because we built the ORM, we're using client extensions, it becomes really easy to use. It's an integrated experience. So if you use the Accelerate client extension and you want to cache globally, it looks like using Prisma. Prisma.user.find many, that's normal. The work clause, everything is normal. The only change is the cache strategy. So there are 2 parameters you can use. You can decide how long do you want things to be cached, that's the TTL. And you can decide, well, if the time is expired, do you want to serve it anyway to make it a faster experience? That's the stale while revalidate parameter. And we're going to go and build products like this very quickly. Essentially, glorified Prisma extensions. Over the next year, 2 years. We're going to release a product like this once a quarter. And that turns into what we call the Prisma Data Platform. We're trying to make building with serverless a delight, the same way that Netlify and Vercel makes it really easy to deploy static sites, front-end applications. We're trying to do that same thing for more sophisticated back-end applications. So we want to enable you to be productive. Back-end developers should focus on your application, not managing infrastructure like Kafka. And the system that you're using should be scalable. It's important to scale to meet your traffic demand, of course, but it's also very important to be able to scale to zero. And a lot of services that are talking about being serverless, they don't do the scale to zero thing really well. And that means then you have to worry about what does it cost me to run these different environments? Do I really want to run new environments for each of my branches? Yeah, you want to, and the system should help you with that. So Accelerate is the first product. That's a data CDN. We haven't really talked about Pulse yet, but that's a data change subscription system. So if any of you are familiar with Rethink, that's the idea, but for any database. We're going to build a system that listens to data changes from the uplog, from the replication system, and then build tools that help you work with that. We have a whole lineup of these products. They don't have names yet, but the icons are designed to give a clue. This idea is also a thing that is kind of emerging in the industry. Some of you might know Sean Swix. He's talking about the self-provisioning runtime. He's been talking about this for a year and a half. I think that's a really good way to articulate it. I know Vercel is talking about framework-defined infrastructure. It's the same idea fundamentally. And the idea is that instead of managing infrastructure yourself, instead of using code to manage your infrastructure, you want a system that just understands your application and ensures that the infrastructure you need is available when you need it. I like to think about where we are heading as an industry as more like a global mainframe. It used to be very simple to deploy an application. You deploy it to the one mainframe and it just works there. It's a long time ago, but we're kind of moving to that same space. And I think Cloudflare is really at the front of this innovation. The compute units you have at Cloudflare are very simple, but they are standardized. So when we work to make our applications work in that environment, then they can deploy globally, they can scale up and down, and there's this underlying system that can manage everything for you. That's all I wanted to talk about. Thank you very much.